finishing up our discussion with control flow statements. So we've done if then else, and switch for decision making statements. We've done looping statements for while and do while. What's left is branching statements, where we'll look at break, continue, then I'll stitch a link to return, which was covered in earlier sessions. So with break statements and continue statements, we have two types. We have the labeled, then the unlabeled, the labeled, then the unlabeled types in each. Then with return statements, which was already covered again in a previous session, and I will attach a link to that session. We have one that returns a value and one that doesn't return a value. So what we'll do in the demo is to look at break and continue, the label and the unlabeled of each, and then we'll call it end of session. We saw this for loop class in the previous session, but we will be working with one break statement and labeled method. I left this here so you would see where we came from the previous session, but we would be using that method. So let's go to the first method, break statement and label. We have an array of integers. We have what we want to search for from this array, which is 12. 12 is in index 0, 1, 2, 3, 4, fourth index. Element 12 is in index 4. Yes. Then we will be working with I to track it. I had said in the previous session, if I will be used in more than one places, you can just work with it as a local variable within the method instead of initializing it within the for loop. In this case, then we're working with the boolean. I found it that is set to false, but will be set to true once 12 is found from this iteration here. So in such a scenario, how does break statements come in? They come in like this. So we have I starting at 0, then shouldn't go beyond the length or it shouldn't be equal to or beyond the length of this array. Then you implement it. So within the loop immediately after, what you'll do is to check I, the element of the index I as it currently stands against what we're searching for, which is 12. And if it's found, then it will set it to true, and then it will break. So what breaking does is it terminates the innermost loop, and in this case it's the for loop. So this will be terminated. It won't go and check for anything more from the loop, no matter the iteration length that is left. What it will do is it will come to the if statement here and check against found it. It should be now set to true and print out found 12 at index with the index number. So we expect to see found 12 at index 4. Yeah, so let's test this out. I made a point of including this as out statements so we can track I, and we can also track the element as it stands. So let's see, within the for loop we'll track in the output how it iterates through all the way to the end. Okay, so here we go. We're starting with I0. I at 0. Then we're searching for 12, while I is now 32 because I at index 0 is 32. So this will not be true. So it means it will go back to the for loop. Okay, and increment I. So the next one is I is 1. Well, we're searching for 12, but it will be 87. The next one after incrementing will be 3. The next one will be 589. Again, in all of the above, this is not true, so it will not do anything within the if statement. But once it finds it, which is at index 12, it will go. This will evaluate to true because it's equal to this, and then we will set the found it to true. And then we will break, and by breaking we will not go back to the for loop. we will just proceed on to the next one. And this is what our code is doing. I keep saying we, but it's not really us directly, it's just what you've instructed your code to do. So here we go. For the labeled one, we'll use this multi-dimensional array to explain it. Multi-dimensional array, if you missed the session, is an array that has arrays as part of the elements. This is array 1 at index 0, array 2 at index I1, array 10 at index 2. So we're still looking for 12, which is in array 2. Now iteration will happen twice, first in the arrays of arrays, then in the individual arrays at that moment. So this one is initialized, or is left as it is without initialization, because it's part of the outer loop and we are sure that it will at least run once. So I will always have a value which would be 0, even if the for loop does not run. But with J, we had to initialize it because sometimes this loop will not run, this loop might not run, and that means the other loop inside it will not run, and that means that J might lead to an error. Let me just demonstrate that. Let's see a more specific error when I run it. This one, variable J might not have been assigned. Okay, just so you know, expect that it might seem like an unexpected behavior, but really it is a right function as well. So J is initialized to 0. Okay. Now again, we can track our I, and we can track our J's. So because we are working with a multi-dimensional array, we need both I and J to know where we are at in the search. So if the result of this multi-dimensional array is equal to 12, that's when we will work with the if statement, as we've done in the previous example. Otherwise, so I starts at 0 and J also starts at 0. So 0, 0 would be this first array element 0, which is 32, and so on and so forth up to when we get to 1, 0. So let's run 1, 0. That was the last one. So 1, 0 resulted into the 12, and here it is found at 1, 0. That's how we do it. You can just take time to look through it at your own pace so you'd understand what's going on in each step. When working with I and J, because it's a multi-dimensional array, we also need to know that this one is tracking the length of the outer array, which is array of things, but this one is tracking the length of the arrays within the array. Like in this case, it should be less than this length, which is 4, should be less than this one is 4, and this one is 4. So even when you look at the output, you will see that it's going, the inner loop is going on all the way up to 3, and then it stops before it goes to the next one. Next, we have the continue statement that is unlabeled. We will be working with a string search name, and we will be having a counter for what we'll be looking for, which is a character P. Then we have our for loop here that shouldn't go beyond the length of the string. Then we have within the loop an if statement here. So this if statement should look at this string and then find the character at that point, and if it's not equal to the character we're looking for, which is P, then it should continue. We use this out statements again to print out, so you can track that, track the output. Okay, so let's see. We are starting with P at 0, I at 0, and we are checking if the character at 0 is a P. So we found the first P. Then again after that, so we're here. Okay? It is a P, so it will, this will not evaluate to true. This evaluated to true, then it will go back to check. So this will not evaluate to true, it's a P. then it disappears for Peter, and then it will add the number, increment the number, the value at num p's. So we have it at 1. Okay, let's continue. We have the p, tracking p count to 1. Then we have tracking I at 1. Once it's incremented, let's check if this is a p. It's an e. In the others that are not p's, what will happen is once it's done, so is this a p, then it's an e. What will happen is if this is not a p, then continue. So it will not increment this, it will just go back to this part of the for loop. Please take time and understand if that might be a bit confusing to look through that again. So the continue statement will be labeled. We are working with a search string. Look for substring name, and we're searching for sub. So this file here, and we're setting the boolean, found it to false at first. Then we are working with a max length of the substring minus the length of the search main minus the length of the substring. So I will use this to show us what that math evaluates to. First, before I continue, instead of counting manually, so this is 26, so, and this is 3, easier to count, then the difference is 23, so we're working with the max value of 23. Keep that in mind, but you don't have to, I'll just show you that again. Then we have some more initializations to do within our for loop. So this is a labeled one, so we have a labeled outermost loop, we are labeling it test. Then in that loop we have some initialization. We're initializing the variable n to the length of the substring, which is 3. We're initializing the integer j to the value of I. We're initializing the integer k to 0. So let's just track this and see where we're starting from. So here we go. Before we start with an I of 0 and a j of 0 and a k of 0, and is 3. I of 1, j of 1. So I and j, the value of I, the value of j is set to the value of I rather. Then n remains as it is to 3, 3, 3, 3, 3, 3, 3, because it is initialized to this without any incrementing going on, at least not in the outer loop yet. Then k is also at 0 because as we are still in the outer loop, none of the changes have been effected. So when you go into the inner loop, the while loop, we are saying that take n and decrement it, so the value, and check if it's not equal to 0. So 2 is not equal to 0, so definitely it's true. Then it goes inside this loop. So let's see what happens here then. Once n is incremented, what's the value? What are the new values? What's the new value of n in relation to the other values? So again, we go. Before we start, they're all i's to the original values as they were. So I0 is 3, j0, k is 0. When you increment the I, it increments with the j, but then n remains to be at 2. Okay. All the way up to when it doesn't. So let's find out what's going on here. Okay, we have this if statement, and it is checking the character at j plus 1. So whatever value j will be incremented, that's the character that it's checking for. And what it's checking for if it's not equal to the character at the value of k incremented. So I'll go back to this to show us what k is. Please check and confirm that all the way from the top, k has maintained the value of 0. So that means when it's finally when it's compared here, then it will be a 1 character at 1, and that character at value at index 1, or not really index, character at 1 is id. here. So we'll be looking at the character at search me, the original string that we are searching for, and if it's not equal to the character at 1, sorry, in the substring, which is the u. So if it's not equal to u, then it continues to the outer loop. So it will continue from here. You can work with this to check out the last character. So there we have it. Last checked, s is not equal to u. So the last thing it checked was s, and s is not equal to u. So the next one obviously was u. This will help us track the value of j plus 1 and the value of k plus 1, and we'll be able to confirm that the last value was 11 before the while loop was completed, because as long as this value is not true, as long as the character at search me that has been found at that moment is not equal to the character of substring, then it used to go to outside loop. Otherwise, it will not go to the outside loop, it will go to the while loop and continue on by decrementing an even further. So it will start with an n of 3, then go to 2, then 1, then 0, then that will be that. So in an earlier session, I'd asked you to check out the post increment versus the pre-increment. Yeah. So this is a very interesting thing I found out, that if I work with this post decrement as it is, then and I run this, I will see that it will still run this even when n increment evaluates to a 0. So you see, after while loop value still runs even when n evaluates to a 0, even though you might expect that it shouldn't be able to, because then that value at 0 is not, as long as n is not equal to 0 is when it should run. But this is a post decrement. So if it's a pre-increment, you'll notice something different, where we would see the 0. So remember, one evaluates to the original value, the other evaluates to the value after the decrement. Like you see here, the last after that was printed was the 1 and 1. The result is the same, but it's interesting to note that your code will behave different, I suppose, in a way.